All right, let me make sure. So can you see my screen okay? You should see a giant function called localize. Excellent. Let me know if the font is too small. I was trying to adjust between font size and readability. I think one of the examples later, I might need to bump the font size down to fit it on the screen, but we'll see. So there is no match case statement here. What I have up is actually Django. So I have checked out the Django source code, and I can actually run tests against the Django source code. I'm running not the whole test suite because it takes a little while. This little bit here only takes a couple seconds to run. And I'm running the test only against pretty much template tags and some internationalization code. And I basically went digging in the Django code base, since it's open source, you can, for things that might work well with the new match case statement that's going to be in Python 3.10. So instead of explaining what match case is, I'm just going to show you what it looks like. This is an if-elif chain. So in other languages, you might have a switch case statement. Match case is not switch case. Match case in Python 3.10, similar sort of to switch case in Java, JavaScript, lots of other languages. Not similar in how it's actually used. It's quite a bit more powerful than switch case. So this giant if-elif here, you notice it's asking if all these things are instances of something. That's really the sole question that's being asked in all of these. This one's interesting because it actually asks if it's an instance of a few different things. So what this looks like with match case, I'm going to flip my screen here, is this. So what we started with was this. We have if is instance value stir, elif is instance value bool. We get match value, case stir with parentheses, case bool, case. This one's interesting. Decimal, pipe, float, pipe int. So we're asking, is it any of these things? So the bitwise pipe operator does something special here. It's not a bitwise pipe operator. And in fact, the parentheses are not calling stir. The fact that there are parentheses after that basically indicates to Python, this is a class. It's a class, it's a type, and we're asking, is the thing an instance of this type or of this type or of this type? This is one of the reasons match case is so controversial in Python 3.10, because it kind of fundamentally changes some bits of the language. It adds things that aren't just, oh, here's a new syntax. It's here's a new syntax, and this little bit in here has also different syntax. It's almost like a mini language within a programming language in a sense. Not quite as bad as say regular expressions being a mini language in a programming language, but it's pushing in that direction a little bit in that it's kind of a subset of Python within Python. So this is one example. One thing I will note, that underscore at the end, this is actually special. Underscore normally isn't special. This underscore actually does not bind to this variable, and it's a way of indicating in match case, this is the otherwise case. This is the one that catches everything at the end if nothing else matches, which was a little bit odd, that it doesn't actually bind to underscore, it's special. So this is one example. I guess I'll take questions on this example before we move to another one. If anyone has questions. If you want to save them to the end, please feel free to save them to the end. I'm hoping this will be about a 10-minute lightning talk in total.
I have a quick question.
Okay.
So what happens if you don't include the catch-all case statement?
Great question.
Nothing matches.
It just falls through, kind of the same way as if you didn't have an else, it's actually falling through to return value. So in fact, in this particular case, it's a little redundant. I could have just put return value at the end. Yeah, great question. Yep.
If there is no return at the end, does it return none like most functions and methods in Python?
Yeah, so match case, this particular example is all about return. It doesn't actually have anything to do with return per se. It's executing this code and only this code. Unlike switch case and other statements or in other languages, though, which is I think is what you're asking, it doesn't fall through to the next case. There is no equivalent of a break. So in switch case in a lot of languages, there's switch case break, case break, case break. There's no break. It's only one of these is going to match.
So assuming that there's no case at the end, then where there is no value it matches, it falls through all the case statements. What's the behavior there?
If it doesn't go through all the case statements, it will continue on to the next line of code.
Okay, thank you.
Yeah, you're welcome. Which is the reason I say it's redundant in the sense that it's the same as this. Kind of the way the original authors actually wrote just return value, which I might have written else return value. Some people prefer return value. There's not a right or a wrong one, except that everyone thinks there's a right or a wrong one. This is the same thing. So this is absolutely equivalent. And in fact, I can prove that. Oh, I need to put the return out here though. This indentation is a little bit weird with match case because it's like double indented because of the case. Should pass the tests. Let's make sure I didn't. Yes, it does pass the tests. Obviously, I'm not going to make this a pull request to Django because they would have to drop Python 3.9 support to actually make this work. So next example, this is a very simple one. This is not in Django. This is some of my own code. If you're part of the Python morsel service that I run where I send out an exercise every week, you might recognize this little function. There's a try except here. Now we're checking basically if when we split on colon, if the number of things we get is 3, then it's hours, minutes, seconds. If it's not, if we get a value error while trying to do this unpacking, we say, well, it must be 2. We set hours to 0 and unpack in minutes and seconds. With match case, it looks like this. So we're matching on this thing. Now notice we didn't even set sections as a variable. We don't have to. We're saying match on this little object we get. If it matches minutes and seconds, so this is where switch case and match case really differ. We're matching on an unpacking basically, saying if there are 2 things, take those 2 things, assign the minutes and seconds variable to the first and second thing, and then assign hours to 0. Or in this case, assign hours, minutes, and seconds to the 3 things in there, and then do nothing, which is a little bit of a strange way to do this, but it works. I don't know if this code really should be written this way, but it certainly works. And in this particular case, we could even have an otherwise case. We could say otherwise, there's some particular exception we want to raise. And it really lets you know that, in this case, we're overlooking a possible exception here. Here, if you don't have an otherwise case, that means there's something missing. It's a little bit more obvious something's missing. So one benefit of match case is it's obvious something's missing here. So another Django example related to this, do get language info. Down here, this is in Django's parser. So it's saying I'm parsing a template tag in the template language in Django. Get language info is the name of my template, which means the very first argument we're going to get when we split on the tokens, arg0 is going to be our template name. And in fact, that's what's going on here, args0. Args1 is, it has to be 4. And so in fact, it's checking here, if we don't have exactly 5 arguments, or argument index 1 is not 4, or index 3 is not as, this is not in the right format. This is a malformed use of this template tag. Therefore, we raise an exception, complain that this particular name of the template tag has, these arguments that aren't valid. Otherwise, we grab argument 2, which is the language code we're working with, and argument 4, which is the variable we're assigning it to in the template language, and we do something. In match case land, it's a lot simpler. This is where things really start to make sense with match case. We're matching with the case of the tag name, the string for, the code, the string as, the variable. This is the success case. It's the only success case. In any other case, we've got our tag always. Everything else, we're going to complain about that. And so one thing that's nice here is over here, it would have been painful to do a tuple unpacking. To say, I mean, we could have done a tuple unpacking. We would have had to do it down here though, to say tag, comma, I guess 4. I don't know what you'd call this. Code, comma, is this our as? Yeah, this is our as. Variable equals args, something like that, and then use those variable names down here. In match case, it's natural. You can just stick it straight in the case. So I see a question in the chat. So is the match var case thing 1, thing 2 just swallowing the value error? It wasn't. Well, sort of. It's not actually getting an exception. It's saying if, is it getting an exception? I don't think it's getting an exception. And the reason I say that is it's trying to unpack this and it's using the iterator protocol. It probably gets a stop iteration exception, not a value error. And the reason I say that is it's looping over this thing. It's some kind of iterable. It doesn't have to be a list or a tuple. It can be any iterable. I believe so, at least. I haven't played with this that much, but I'm pretty sure it can be any iterable, which means it's relying on the iterator protocol the same way tuple unpacking does. So it's swallowing a stop iteration exception the same way a for loop would. So it's kind of like a for loop under the hood in that it's looping 2 times to grab those things. I don't know what it's doing in the multiple cases situation though. Does it loop? Does it exhaust if it doesn't need to? I don't know. Um, I would guess it always exhausts because we are inherently matching against everything. But that's a great question. You could actually play with making your own custom iterable and seeing what it prints out when you actually use it with match case. It's probably also an implementation detail that might change by the time 3.10 is released. So another example, and by the way, if you check out 3.10, the development version, it doesn't yet work with match case. You have to check out a pull request where it's currently in active development to add match case to 3.10. It happens to work. At least that's what I'm using here, and it works. So this is an interesting example because we're doing a similar thing. We're checking if there are not two arguments, we've got an error. If there are two arguments, we grab the first one and check to see if it is not on or off one of these two strings, that's an error. So we don't just want to match on two things. The second thing has to be either on or off. In match case land, it looks like this. The string on pipe the string off. Now the interesting thing is we're also saying as arg. This is a way of saying I want to match on two things, but I also want to capture whatever the actual value is into arg. And then we're checking down here if arg is equal to on, then we do the thing that we were doing the same as before, arg equals on. Otherwise, so we've put the thing we're matching first. Our exceptional cases are later. Otherwise, if we have two things, but it's not on or off in the second place, we say it should be on or off, we complain. Otherwise, we don't have two things, so something's gone terribly wrong. We do the same thing we were doing before. We say it requires exactly one argument. We were just doing it in the opposite order before. So we get to put the first thing first, which is kind of nice with match case. It's a success case. All right, some questions in the chat. Why did they make the switch match different from? So the reason they use match instead of switch, I think is what you're asking, is it isn't switch case. If they had done switch case, I would have been personally really confused because I would have thought it was a switch case statement. It's not a switch case statement. There's no break, and it doesn't do an exact match. It's doing a kind of a fuzzy match in a sense, and the semantics and syntax within this little line are special just for case. So I think that's the reason they use match case instead of switch case. Is it's very related, but it's not the same thing. Kind of like how generator functions are related to functions, they're not the same as functions. I wish it wasn't def something to make a generator function, but gdef or something that let you know when you're just looking at the top of the function, this is not a function, it's a generator function, but instead it's that magical presence of a yield statement in a function. Rationale for match case is more readable Python code. I would agree. Yeah. So the next example is a very big one. In fact, it's entirely a doc string. This is cycle, the cycle tag in Django's template language. There's quite a bit to the cycle tag, which is the reason there's such a long doc string and the reason the code is very long. So the code looks like this. We check to see, are there less than two things? If not, are there equal to two things? If there aren't, are there greater than four things? If there are greater than four things, that means we have silent, hopefully. Well, maybe. If we have silent, if we have as in the third from the end, silent has to be the very last thing. If it isn't, we get an error because as third from the end means silent has to be the first from the end, which is a very weird way to write what they're trying to write, but they kind of have to write it that way. Otherwise, if as is second from the end, that means there's not silent. We're saying as some variable name, that's the last thing. And we have this as form equals true, silent equals false situation, then we use our toggling down here. So in match case line, the thing that changes is basically this whole else, the if checking up here. It looks like this. We can say, like we were doing before, if there are less than two things, meaning there's really just one thing, we have our error case. And we could have put that at the end, in fact. It doesn't matter where this goes, because matching two things is never going to match this. So matching two things, grabbing the name, that's a pretty simple case. When it gets weird, though, when you get more than four things. So more than four, that's where you've got a whole bunch of things you're cycling through, and we can grab those with asterisk, then as, then name, then silent. This is the silent case. Now, if we have something here that is not just silent, that means we raise an exception. So this is a lot more clear to me what's going on, as opposed to this with the silent is not -1, then we raise an exception. It's kind of a weird way to say this. This is a much more straightforward way, I'd say. And then if there's not silent, there's not silent. It's a little bit more clear what's going on. And in this case here is kind of our fall through, normal case. And then everything down here is mostly the same. So match case in this particular situation, in Django's template, can we see the first example side by side? In Django's template language, I would say it makes things a lot simpler. So I think you're asking the first example, localize. Is that right, Thomas? Right here, you want these side by side on the screen? Yeah, let me bring up, if I can, Django utils formats old. So side by side, I'll try to make my font a little bit smaller here. Oop. So if is instance, we're doing this instead. A lot of case checks instead. Now, one thing I didn't mention is when you're doing is instance checks, there's a lot more to match case than what I've shown. When you have a variable, when you have something like, in this example here, minutes, that is a variable to assign to. If it had been a.minutes or datetime.datetime, that is not a variable to assign to, but a variable to read from. A qualified variable name, meaning there's a period in it, is a variable to read from. An unqualified one is to assign to. That's very weird, but it works. And over here, if you have decimal value, this would be looking for an argument called value. Sorry, now value equals 4. This would be checking that it is a decimal and it has a value attribute which is equal to 4, which is also kind of weird and magical. That's an unusual thing to be checking there in Python. So there's a lot more to match case than what I mentioned, but I'm over time more than I expected to go here. So I'm going to wrap it up. If you got questions, you're welcome to ask in the chat. I can, maybe answer during another talk later or right now. I don't know if I'd have the answer to your question necessarily because I've read the PEP on match case and I've written this code here, but that's about it. Thanks for the question so far, though. Yeah, we'll have to get used to it. Well, I don't see any questions in the chat, so
Any other
maybe I should push
questions?
back to you.